Hey, today we have 648, a redundant connection. And in the problem, a tree is undirected graph, connected and has no cycles. Okay, so yes, true. You're given a graph that starts as a tree labeled with additional edge. Added edge has two different vertices from choose from 1 to n, and there was not edge that already existed. Okay, the graph represents the array of edges lengths, indicates the edges between nodes. Okay. Return an edge that can be removed from resulting array is a tree if n node. If there are multiple answers, return the answer that occurs last in the input. Is it can be removed, so the result graph is a tree. Okay, so if we remove 3 to 3, yeah, it will be 3. If we remove last one, right, 1, 4, it will be 3. Okay, so if array begins as a tree and then closed into graph, what we can do, we can first we can create adjacency list. That keeps all connections. We iterate through edges, create adjacency list. For every new node, check if connection exists between these nodes. These nodes. If does exist, it does return nodes. We found our results. If not, just continue. So yeah, so it's basically 3 steps. To find connection between two nodes, we can use 2 methods. We can use DFS and we can use union find. And for this solution, I will use DFS. And so first, we declare adjacency matrix, and let's call it connections, and it will be default dictionary list. It will be list of lists, hash table of lists, or like dictionary of lists, and then mine cycle will be for e in edges. What we're gonna do, we're gonna call DFS if DFS between let's unpack E with AB equals E. DFS AB, we return E. Otherwise, we add connection E A append B and connection B append A. So DFS, our function, will return if connection already exists. If connection is not exist, if connection already exists, we found our problem chain. If not exist, we just continue and appending things, appending adjacency matrix, right? So let's go and implement our DFS function. So it will accept a B. If A equal B, we return true. return true. Otherwise, for node in adjacency matrix connection A, we return DFS. So this is return true. We return DFS and B, right? And at the end we return false. False. The only problem is here, I can tell. So we have to track visited when we go into DFS. So let's declare here because otherwise we will continue going through the same nodes like 1 2 2 1 1 2 2 1. We have to keep visited nodes. So for that we will, but we have to go for edges in right here. So we declare self visited. It will be a dictionary of Boolean, and if visited and if visited A. Add visited A equal true. So we're not gonna fall into same node over and over again. Okay, let's try. Network error. Okay. What is going on? Okay, it's back. So now let's try and run this code. DFS is visited is not defined. Yes, self visited. and in connection does match my outer. Okay. For every age self-visited default dictionary we call TFS. So let's try run this for this example. So first we take 1, 2. We create a default dictionary and then we call TFS with 1, 2. Not equal, not visited. We added visited true. Connection nothing. We return false. Then we add adjacency list. So our adjacency list will be connection 1, we'll have 2. Then we go 1, 3, the same, not invisited. 1 is invisited. No, we created, so 1 is not visited. We go to 1, 3, we created, we go to here, 1 is not visited true. For connection 1 to 2, we call DFS 1 and 2. So we call DFS for 2 and 2. 2 is to the same. Okay. I'm not sure if this is correct. Let's call it if DFS true. Okay, so this is how it should work. Let's try to submit. And it's working. 36.62, okay, not bad. Let's see what is super faster. Yeah, Union Fine. Nice and clean Union Fine. Yeah, Union Fine will be faster in this because we don't have to do walking through all the time. We just union and return H. If not union. Yep, very nice and clean code. Well, that's it for today. Thank you for watching.